All right, good morning, and thanks very much for this kind introduction and the invitation to speak with you all this morning. As was said, I'll talk about this a bit from an animal health perspective, but also from a broader sustainability perspective in terms of the animal piece of this dynamic that you all are digging into deeply this week here. So to get started, you heard my bio, but currently I'm at Colorado State University at a unique program called Ag Next. And so this is the mission and vision of Ag Next that's on the slide right now. What is unique is that we've only been around for a couple of years and only had faculty in this effort basically since end of August, which is when I started with Colorado State University. And this effort is really focused solely on sustainable animal agriculture, and so that makes it unique across land-grant universities in the United States in terms of a multidisciplinary focus on the three pillars of sustainability: economic viability, environmental stewardship, and social responsibility, under which things like animal welfare and, of course, animal health as a cross-cutting issue affects all those different components. As a part of Ag Next, though, and again, what makes this group unique is that there's a diverse array of faculty. So there's animal scientists like myself as a part of this group, but there's also agricultural economists and folks who are focused on modeling, right, from a life cycle assessment modeling standpoint, looking at the impacts or the benefits of production systems from cradle to consumer, basically. So again, we have a multidisciplinary team, and I really just wanted to give that pitch. If you haven't heard of Ag Next, please check us out, and we really are focused on this issue of sustainability 100% of the time from a transdisciplinary research perspective. So when we think about health, I think it's important to start off with what is health, right? And of course, we can think about health as a standpoint of being free from disease, right, or sickness or illness, but it's also about a system's capacity to deal with shocks, right, to deal with changes. And so really it's also about resiliency and the capacity for change, right, and the capacity to deal with an environment. So the reason I bring this up is when we think about applying this health idea to this topic of the day, right? We think about the topic that you all are taking on in terms of grasslands and how they intersect with plant, animal, soil health. It really falls under this One Health definition. This is probably nothing new to a lot of you. This is something that's been around here for many years, this idea and concept of One Health. It's been codified by many of the international organizations that we were just talking about from a standpoint of the International Year of Rangelands, right? But One Health is that integrated perspective of thinking about ecosystem health, animal health, both from a standpoint of domestic and wild animals, and how that affects human health, right? And a key driver of this, of course, is thinking about things like zoonotic diseases, right? Most of the diseases that we interface with, right, roughly 70%, are zoonotic of origin, whether that's coming from wild animals or domestic animals. So that's always a key component when we think about this. But again, it's about that broader concept of health and a system that can deal with, right, challenges and shocks, and still, of course, when we're thinking about our food system, produce nutrient-dense food for all of us. So I would say this concept of One Health is very much related to and integrated into this broader concept of sustainability, right? This is a word that sometimes gets overused, and it's a challenging word to sometimes pin down a single definition for. But when we think about sustainability as it relates to food systems and animal agricultural food systems, there is broad agreement that it's about three main areas, right? We have economics, social areas, the environment, but it's also about a long-term perspective, right? It's a system that can try to balance all these competing interests, but do so in a way that doesn't sacrifice the ability of future generations to meet their own needs. So as you look at this slide, it's quite complex, right? There's many different issues that are listed either within one of those single domains or, very importantly, within those areas of overlap of the Venn diagram, right? And that's where we have areas where we can sometimes have synergies, right? Things that work in concert. And as I'll come back to a couple times in this presentation, oftentimes animal health and environmental health are closely linked, right? From a standpoint of course, the environment influences animal health, but also when we think about improving the health of animals, improving their well-being, oftentimes there's a productivity benefit of those animal systems, and that often drives down environmental footprints, right? So that would be an example of a synergy. But there's also oftentimes trade-offs, and we'll talk about that too in this presentation. And that's one of those challenges, is having the right information to deal with those trade-offs, because sometimes you can't have your cake and eat it too, right, in this conversation about food security and sustainability. So when we think about those research needs, I'll talk on some of these things, particularly the feed-food competition and the idea of circularity. But it's also important, that last bullet point, right? When we think about this topic of health or sustainability, it's not a perfectly objective conversation, right? And we all know and have seen a lot of the headlines that are somewhat related to this topic, right? And so these are just some of those headlines. Things about greenhouse gas emissions, antibiotic use, in terms of thinking about alternatives to meats, right? All of these conversations are bubbling up in the public sphere and really are important, right? And I won't have time to cover each one of these topics in detail, right? Well, I'll just kind of give you a surface view of some of these issues. But I put these headlines up here mainly just to say these conversations are merging all these different topics, right? Human nutrition, health, ethical use of animals, and really they're about questions that society is asking that could be summed up as what I'd like to say should questions, right? How should we be producing food, and what should we be eating, right? And again, that's where that value judgments piece comes into play. As soon as we start using the word should in questions, we've departed the land of objectivity, right? Evidence is important in terms of making those decisions, but we also have to recognize and grapple with the fact that a lot of these things are about different that people are bringing to the conversation. So one of those key issues that comes up again and again and does intersect with animal health, as I just kind of referenced when we think about the productivity of an animal system, is greenhouse gas emissions. And as you saw from some of those headlines, this is a repeat theme in terms of what comes up again and again from a standpoint of health or sustainability of our food system. So a little bit of context, if we looked at the entire global livestock sector, so this is beyond just ruminants, right? Cattle, sheep, goats, buffaloes, pigs, chickens, the whole system, right, from a global perspective, around 11% of greenhouse gas emissions in the world come from livestock production, okay? And as you look at this Sankey diagram, right, it's a little complex in what it's showing you there, but there's a few different themes here, right? If you look to the far left, this is just showing you where are these emissions coming from, what species of animal. The majority come from cattle, right? And that is a biological reality because as you follow that line through, most of the emissions associated with cattle are the methane emissions these animals naturally produce, right? And so that's really what drives their higher footprint relative to some of these other species. But there's a variety of that we need to pay attention to when we think about livestock greenhouse gas emissions, right? All the inputs that go into more intensive systems, right? Things like nitrous oxide emissions are a key source as well around the world. So this is the global picture. If we think about it in the United States and think about what's changed over time, right? This is information from the US EPA, okay? And so on the y-axis, we have million metric tons of carbon dioxide equivalents. This is just a way of accounting for all greenhouse gases and trying to put them on a common basis, going from 1990 to 2020. And you'll note these different colors I have here denote different species of animals, and I've put direct as a label on each one of these. This means truly just the emissions that are coming from the animal itself and its manure. Okay, so we're not accounting for feed production and all those other aspects that would go into a life cycle assessment. The reason I share this with you is just to give you an idea that over time in the United States, we've had relatively stable, but actually an increase in total emissions from animal agriculture. Okay. Now, if any of you are familiar with animal agriculture, also we've had a tremendous increase in the total output, right, from animal agriculture as well, right? But that is the reality of where our emissions are coming from. And you'll note there's two main categories that have really increased, right, dairy and swine. That increase is actually not necessarily from enteric, or the naturally produced methane emissions from the animal, but actually primarily from manure methane emissions. As those systems in the United States have become more intensive, and we've increased their total productivity, right? We've also housed animals more in confinement, right? And in the United States, we've had to respond to different legislation to protect water quality. As a part of that, We've actually had more liquid manure storage, more anaerobic lagoons where we've stored manure in the United States. So we've tried to solve one problem from a standpoint of water quality, right, and not spreading manure all the time, but doing it in ways that make agronomic sense. But while we've done that, we've created another challenge, right, of methane emissions, right? So back to that idea of there's always trade-offs in these systems. So as I just mentioned, right, the productivity of those systems has actually increased tremendously since 1990. And so if we put those two things together, what we're looking at here is the emission intensity of beef and dairy and pork production in the United States, meaning greenhouse gas emissions directly from the animal as manure per unit of production. So as we look at those statistics over time, right, we see a decrease. Despite that shift in concentration and intensification, we still reduced emissions per unit of production. So I'll come back to this. This is important, right? We need to stop increasing total amount of emissions, but decreasing emissions per unit of production is very important, especially as we still have a growing world population, right? And that's whether it's in a grass-based system or a more intensive system. That matters in both situations. Right? In the United States, cattle production is our main user of grasslands, right? And our main ruminant production system for meat in the United States. And so there has been life cycle assessments done of U.S. beef production in terms of looking at all the impacts going from cow-calf production to an animal leaving a feed yard and going to a packing plant. And so that's what's summarized here is some of that information on the life cycle assessment of U.S. beef in 4 different impact categories. So in the upper left-hand part, we have greenhouse gas emissions. Moving over to the right, energy use, blue water use in C. And if you're not familiar with blue water, or you think, isn't all water blue, right? It's a different way to categorize water use within a system. Blue water is surface and groundwater rather than precipitation, right? If any of you are familiar with water footprints of livestock, sometimes precipitation is counted against the water use of livestock, and so that's not included in this assessment. And the final column is reactive nitrogen loss, right? So there's a lot of information on this slide, but the key things are summarized here over to the right, right? About 3.7% of U.S. greenhouse gas emissions comes from U.S. beef cattle production, okay? The biggest chunk of that, if you look at that pie chart, is enteric methane, right? That's where most of our emissions are coming from. But there's not insignificant amounts of inputs, right? Resource inputs going into the system, things like fertilizer, or nitrous oxide emissions that come from soil that are also contributing to that footprint. Energy use is very minor in the US in terms of the total contribution that beef makes, but it's not an insignificant amount of energy that goes into the system. That upstream category is more of things like the energy that goes into producing fertilizer, right, is actually the biggest chunk there. Blue water use. This is important not just for beef, but for all livestock systems. Most of the water use within that system is actually tied up in feed production, right, in terms of irrigation water. It's not the animals are drinking inordinate amounts of water, right? It's more the irrigation water that goes to produce animal feed. And then finally, that category of reactive nitrogen loss. So reactive nitrogen is all forms of nitrogen other than the nitrogen gas that we're breathing in and out right now. This is a really key and important, sometimes overlooked issue in agriculture, not in the Netherlands, but sometimes overlooked issue in agriculture in terms of the total amount of nitrogen that's used and the reactive nitrogen emissions that are produced from agriculture, right? So you guys can see there the stats in terms of the total reactive nitrogen coming from the beef cattle industry is far greater than the greenhouse gas emission % contribution, and that's just true across all animal and just crop agriculture as well. Right? That's the user of nitrogen in our economy. So that enteric piece, what are the things that we can do to mitigate enteric methane, right? So this is a summary from a nice review that came out last year, and you'll note a few different categories there of management, diet formulation, ruminant manipulation. On diet formulation, you'll note decreasing forage to concentrate ratio, right? And this is another great example of a trade-off and a challenge, right? We know, and it's very well demonstrated, if we feed more concentrates to ruminant animals, right, more grain to ruminant animals, we will decrease methane emissions, right? But of course, when we're doing that, we're kind of a little bit defeating the purpose of what ruminants do in our food system, right? We're now creating more feed-food competition. And so that's one of our challenges is mitigating those methane emissions, but doing so in a way that makes sense holistically, right? In the upper category, we have animal and feed management, right? So there are some key things there that are highlighted. Improving animal health is one of those key ways that we can do that. And so how is that a possible connection, right? How does animal health relate back to enteric methane mitigation? And it's really more from that systems lens, right? When we think about the ripple effects of animal health. And so this would be one example here, looking at it from a dairy cattle example. If we think about all the influences that can lead to an issue of, in the middle there, sick dairy cow, right? She has a clinical illness or subclinical, say, mastitis or ketosis, whatever the issue is, right? What are those different factors that can affect that, right? We know, of course, it's that disease potential pressure, the environment that she's in, metabolic conditions, and all those can have an effect of potentially, one, decreasing the productive life of the animal, right? So mortalities of livestock, whether they're in grassland systems or intensive systems, are a very costly thing from an environmental health perspective, right? Because, of course, we put resources into this animal, and we haven't necessarily returned the human nutrition back out of it, right? And so that's a huge challenge from a systems perspective. So decreased productive life, decreased productivity, meaning decreased yield in this example. All of those things combined from a systems perspective can actually increase the amount of greenhouse gas emissions produced per unit of product, right? So again, that's how animal health is so critical to this, regardless of the production system type, is it really is about effective use of resources, right? And from a standpoint of decreasing waste, right, in the system. So that's how animal health can intersect with this. And we also know there are things like genetic selection opportunities in this enteric space. And so here I just wanted to share with you some of the data from what we've collected at Colorado State University. So these are 99 steers where we measured methane emissions, feed intake, and body weight gain over a period of a couple of months. And so on the y-axis here, we have methane emissions in terms of grams per day for each one of these individual steers, and their feed intake expressed in pounds of dry matter intake. And this color scheme for these different dots is just different average daily gains, also expressed in pounds per day. And what I've done here is just highlighted, one, we know that feed intake drives methane emissions, right? These animals are eating a higher forage diet when we look at this data, but there's also a lot of spread around this line, right? And just to highlight these two individual steers that I've highlighted, right? These animals were gaining pretty similar, eating roughly the same amount of dry matter intake, and yet they had a 24% difference in methane emissions, right? And so these are some of the things that we're finding when we look at the actual data, right? And start measuring the phenotypes of these animals in more production environments, whether it's grazing environments, these high forage diets, or in our case in the US, also high concentrate diets. There's tremendous variation, and that means opportunity most likely to use genetic selection. The benefit of that from a standpoint of thinking about this from a whole system and the health of the system is ways to potentially mitigate methane emissions that make sense economically, but also doing it in environments like grazing systems where it's highly unlikely you're going to deliver a feed additive, for example, to mitigate methane in those systems, right? But permanently reducing methane emissions via genetic selection is an exciting opportunity. So that's the climate change piece of it. And of course, as a society, we talk a lot about this issue because we're worried about the health implications for us, right? In terms of our infrastructure, our ability to deal with change because of climate change. But there are bigger macro issues that are really important, and I'll talk about this more from a standpoint of thinking about it from what we all know of dealing with an increasing population, thinking about food competition, and how we ensure that we're actually nourishing everyone in a sustainable manner. So global population, this is something that I feel like in every agricultural conference you hear about this, right? There's going to be 9 billion people by 2050, right? And that's probably going to happen, right? We are headed in that direction. We're over 8 billion people on planet Earth today. And so what we're looking at here is population on the y-axis and going from 1950 to today, and then projected out into the future where we're going. But the way I've presented this is a little bit different than typically how we think about it, right? This is looking at rural population versus urban population, right? So really where people are still growing, right, where we have an increase in population is urban areas around the world, right? And particularly in developing countries, especially on the continent of Africa, right, we see a lot more urbanization and increasing population. But rural places in the world are actually basically already at their peak in terms of global population and going to start to decline, right? So 2007 was a key year where really that switch happened, right? That switch happened in a place like the United States over 100 years ago in terms of more urban than rural people. But now we've seen that globally, right? And that's just accelerating. The other key thing is we often hear people talk about exponential population growth in the world. That's not true, right? The population is growing at a decreasing rate, right? So really from an agricultural perspective, when we think about environmental health, animal health, we have this challenge of the next 30, 40 years maybe of still growing population with one planet Earth, and how are we going to nourish everyone? And then once we get past that, we'll have a declining population, and that's a whole nother set of problems, but we won't have to worry about that. Most of us in this room, right? We'll be gone. It's somebody else's problem. But right now, we have this 30, 40-year crunch. So how have we responded, right? We often hear about land use change, land use expansion. It's a key issue and one of the drivers from a standpoint of biodiversity, habitat loss, environmental change. But if we look at the data from the UN FAO, what's interesting is there hasn't been a huge expansion necessarily of agricultural land, right? So these are trends over time from 1961 to 2020. And you can see the increases in terms of how much expansion has happened in aggregate, right? And this is important, right? Because some parts of the world have expanded more and other parts of the world have basically, quote unquote, gone back, right, to other uses. So cropland has increased over that total time frame by 16%. Grassland's roughly the same. And as I've kind of highlighted here, since 2000, we've actually decreased the area of grasslands pretty significantly in the world, right? What's amazing is that if you look at that agricultural land per capita, right, that's declined, you know, over this time frame, we started at 3 billion people, we're 8 billion people today. While the food system definitely has challenges and things we need to work on, it is also amazing that despite that increase in population, we have produced more food for more people, right, with less land per person in the world, right? So that is a pretty amazing thing that has taken place. But our challenge is how do we use this system, right, in a sustainable manner to produce that extra 2 billion people coming to dinner, 3 billion people coming to dinner before the actual population slows down, right? So grasslands are a key part of this from a standpoint of land use area. And we see that reflected also in terms of production and keeping up with population in global meat production, okay? So this is looking at from 1961 to 2021, changes in total output from the global agricultural system for terrestrial meats, right? So not including seafood or anything in here, but where is our meat coming from? I think what's key is when you look at this system, if you'll note in 1961, the most produced animal product in the world from a standpoint of meat was beef, and now it is chicken, right? So it's huge changes that have taken place over time. And it's not that ruminant meats aren't significant, but I think this graph is highly related to the prior graph, right? There's just a cap on how much forage there is available for ruminants in the world. And that makes it challenging for those systems to ramp up as much as our monogastric pigs and chicken systems have in different parts of the world. But in terms of why animal health is important, you can see that reflected in this data for swine or for pork in purple. Right? You'll note that pork was the most consumed or most produced protein, and then in the last few years there's been a bit of a stumble, and that is really all due to African swine fever in China, right? Taking a huge chunk out of the total production of pork in the world and the food security implications of that, and poultry overtaking it. Now we have, of course, avian flu, and so this graph isn't necessarily reflective of that, but there may be some dancing back and forth because of animal health issues affecting total production. So similar to that graphic I showed you earlier, when we think about total greenhouse gases from the livestock industry, total protein production, just crude protein coming out of the actual animal protein industry, is about 84 million metric tons, or at least it was in 2015. And the reason I've highlighted this graph is similar to before. We have our species on the left, the actual commodity, and then meat, milk, eggs, and then over on the right-hand side is the type of system where this is coming out of. And I've just highlighted this 46% Mixed systems are getting a majority or primarily a lot of their feed in those systems is coming from forages, and then of course grasslands, forage-based systems. And the reason I'm highlighting this is just to show how important, right, when we think about forage production is in terms of the total production coming out of the animal agriculture industry, right? It's very important. So even though there may be a little bit of a differential there, and of course those intensive systems can produce more output, when we think about sustainable production in a manner that provides all these other ecosystem services with it, this is why, right, grasslands, rangeland systems are so important. And when we think about nutrition, it's more than just protein, as I showed on that prior slide, right? When we think about the health of the human population and why we are doing all these activities related to animal agriculture, a lot of it is more than just the protein that's provided in these animal source foods, but all the nutrients that are coming in that package of meat, milk, eggs, and fish, right? And so the statistic on the top of this slide, I think, is always pretty disturbing, right? 1 in 4 children in the world are stunted, right? They're not meeting their full potential from a physical or mental development standpoint. And a lot of that is due to poor quality nutrition. Not all of it, but a good chunk of it is due to the fact that they don't have access to high quality nutrition. And we can see that in the relationship of inadequacies of different nutrients and the percentage of kilocalories in a nation that come from animal source foods. And so the scatter plot that just popped up on the slide here, that's what this is showing. On the y-axis of those two graphics is the inadequacy of these different micronutrients on a log scale. And then on the x-axis is percentage of kilocalories from animal source foods, not African swine fever, right? I know it's the same acronym, right? But the key takeaway here is over on the right-hand side. Each one of these dots represents a nation, and you can see that relationship for yourself, right? Roughly until you hit 35% of a nation's kilocalories coming from animal source foods, you tend to see more of this nutritional inadequacy, just because it's hard to deliver enough of those nutrients in a nation's food supply without enough animal source foods in that food supply, right? So that's a really key component when we think about the health of all of us and why we have these animals within our food system. So if that's the metric, if we're trying to hit 35%, how are we doing, right? If we look at FAO data, and this is from 2020, the percentage of kilocalories that come from animal source foods in those systems, you can see that chart or the graphic down at the bottom. Hopefully you can see that. The key thing there is that all those nations that are in blue are well below 30%, right? The nations that are red are kind of right in the middle. The United States, surprisingly, we're at around 29% of our calories come from animal source foods, right? Which I think is sometimes surprising to people, right? We eat a plant-based diet here. Basically every country in the world eats a plant-based diet from a kilocalorie perspective, right? And one in the United States is because Twinkies are plant-based, right? We think about that, right? We have a lot of calories in the United States, right? We're not lacking any calories, but that nutrient density piece is sometimes lacking. And we see those countries that are kind of really high in exceptions. A classic here would be Mongolia, right? You're a short grass steppe country. You have a tremendous amount of ruminants. There are roughly 45% plus animal source foods within that nation, right? And that makes a whole lot of sense based on the production systems. So that is the actual data for animal source foods as a percent of kilocalories. And then this issue of stunting that I just mentioned, if we look at FAO data from the year 2020 for that as well, now this is a little bit flipped, right? Blue is a lower percentage. The red and basically grayish colors, we have 30% plus stunting within these countries, right? So there's almost 50 countries in the world where the rate of stunting for children under 5 is over 25%, right? So from a standpoint of health and human development and thinking about why we're doing all this from a standpoint of producing animal source foods and the importance that forage and grasslands has to it, this is a really, really key issue, right? Of the nutritional components of this beyond the other components, which would be, economic development, water quality, all those other factors are important for stunting too, just to be clear. It's not all about animal source foods. So when we think about this from a standpoint of grasslands and kind of bringing that home of, well, what is the value proposition of these ruminants within a healthy food system? I would argue the key thing here is that the fact that ruminants can upcycle plants to more nutrient-dense foods, right? And they're utilizing these lands that are often providing a whole host of ecosystem services, right? Everything from water infiltration, right? Habitat for pollinators for a whole bunch of other wildlife, right? And they're able to cycle nutrients through the agroecosystem, right? So even beyond grasslands, we think about all the other byproducts that come out of our food system that can go to ruminants and produce high quality food. And the reason I emphasize this so much is that I think this is the key thing when we think about ruminant agriculture and why grasslands, rangelands are so important, right? Cellulose is the most abundant organic compound on Earth, right? It's the way that we capture the most solar energy and lock it up in chemical energy, and yet we cannot use it, right, from a mammalian perspective without microbial enzymes helping us unlock that and give us access to that carbon, to that energy, right? And that's what makes ruminants amazing, is they're walking around doing this all the time, right? And unleashing that energy for us in our food system, in our fiber system, right? From biofuels, all these different aspects of our food system. What's key there is, okay, if cellulose is important, well, what are these critters eating from a standpoint of livestock? And this is all livestock, right? Not just ruminant agriculture. When we look at the total dinner plate of livestock, over half of it, right, or almost half of it, is fibrous material like grass leaves, right, from a standpoint of the total amount of feed going into the global livestock system. Crop residues, other forage crops, fodder crops, byproducts, right, if you add all this up, the non-edible, the non-competition feedstuffs that go into livestock, it's 86% of the diet, right, of animals. And that's really, really critical. From a ruminant perspective, our cattle, sheep, goats, buffaloes around the world, it's even higher, right? And even in places like the United States, when people think about beef systems here, they often are thinking grain-finished beef. Even here in the United States, roughly 90% of what cattle are consuming over their lifetime is human inedible material, right? And to that point, when we think about sustainability, when we think about health and trying to put metrics to it, I always use this example because I think it's a good one of one, highlighting this food security aspect, but two, also highlighting when it comes to a lot of this information, you can express data a few different ways and get a few different answers and kind of tell whatever story you want, honestly, from that standpoint. So what we're looking at here is a comparison of grain-finished beef from a life cycle perspective, broiler chickens, and pork production, okay? And we're comparing feed conversion efficiency, which if, again, we're going to talk about feed-food competition and overall producing enough for all of us in the world, that's really, really important for us to think about is what are we getting out of these animals when we put this into them? So this first column is pounds of feed dry matter per pound of live weight gain in each one of these systems. Okay, so again, this is not just a feedlot conversion, but from a whole beef system in the United States. Most folks, when they think about this issue, will stop at this column, right, and compare ruminants and non-ruminant animals and say, well, clearly, if we're going to eat meat, we should just eat, right, chicken and pork, because these animals are far more efficient. But that doesn't tell the whole story, right, from a standpoint of feed-food competition and thinking about what the whole system is providing. Because if we look at that middle column and we think about, well, what are the feedstuffs going into these animals, and are they truly human edible? And here I'm really calling out corn, grain, and soy inputs into these systems, right? When we look at it that way, those vast differences within the systems really go away. And that's just as I mentioned to you, even in the United States, roughly 90% of what beef cattle are consuming over their life cycle is not in competition with human food. And so when we look at that ratio, very similar across the board. The third column, this is a little bit different if you haven't thought about this concept in this way, but this is saying what is the protein value to people in terms of beef, pork, and chicken, and not value like dollar value, but nutritional value, right? What are the building blocks of those proteins, the amino acids? Do they meet our needs? And how digestible are they when we consume these products? So that value of protein versus that same value of the human edible inputs that go into these systems. So when you think about it, again, we're flipping it on its head, and in this case, a higher number is better. If we're above 1, that means the system itself is producing more high-quality protein than it's using, okay? So at first glance, when you look at this with beef, it may seem nonsensical. How can beef actually produce more high-quality protein than it uses, right? But this is the power of ruminants, right? When we think about microbial protein and those animals actually meeting a significant portion of their daily needs just by growing that microbial biomass within the rumen, right? Using a lot of those human inedible inputs, using a lot of that cellulose that is not used in the food system otherwise. That's a tremendous benefit and why that ratio looks so good for beef, right? It doesn't look as good for pigs and chickens because they're like us, right? They're simple stomach omnivorous animals and they have to eat high quality protein. And so they eat more soy and that drives down their ratio, right? So this is a classic example of some of those trade-offs. Pigs and chickens do not produce as much greenhouse gas emissions, that's true. But they also are competing a heck of a lot more with human edible inputs than ruminant animals, right? So which one is most efficient depends on which column you choose, right? My bias is the third one makes the most sense, right, in terms of evaluating the system. But this is where our challenges are, is looking at all these different data, right? And again, most people would much rather eat chicken and bacon than corn soy mixes, right? So at the end of the day, all these animals have good contributions to make, right? And this is not necessarily a new concept, right? This has been going on for a few years, trying to evaluate this, a few decades, trying to evaluate this from a human edible standpoint. And the reason I put this up here is this report is really excellent, even though it's from 1999, it's just as relevant today as when it was published. This CAST report on animal agriculture and the food supply. And as you look at this table over here, these are just case studies of these different countries and looking at milk efficiencies from a standpoint of just gross energy, meaning just gross kilocalories these animals are consuming, versus human edible inputs, and the same for protein. And as you look through here, I really just want to call out some of these systems that in this analysis and others would be considered low productivity systems, right? In Egypt and Kenya, where the total production may not be a lot, but you'll note for human edible returns, there's not calculated listed, right? And one, that's because basically the human edible returns of those systems is infinite because all the inputs going into those animals are not in competition with human food. And I think that's, again, one of those challenges is if we only look at productivity of the system, we miss that bigger picture that these systems are truly creating something from nothing, right? And that's a really key part of sustainability, or again, that health of that whole system is having that capability. So bringing that all together, we think about those human edible inputs, the different components of this. I think we can wrap this up in this whole concept of circularity, which in agriculture is kind of what we've been doing forever, but now it's this new concept, right, in the sustainability space of how can we increase circularity in systems. And here we would just think about an example of U.S. beef, right? None of this is either or, right? We have this connection between cattle production and crop agriculture, and forage production and biofuels production, right? And this transfer of energy and nutrients across all those different components of the food and fiber system. But what's really unique about ruminant agriculture is that uncultivatable pasture rangelands, right? The grasslands piece. Because again, we're bringing in nutrients and energy that we're not able to access in our food system without those critters that are ruminants. So that system of circularity, and we think about sustainability, animal health fits in there, and again, in thinking about how do we make sure that our animals are healthy, that we're not putting inputs into the system, that we're getting nothing back out, right, from a standpoint of mortality and disease is incredibly important, right? And not adding extra inputs to try to put a Band-Aid on some of our issues rather than thinking about health from a sustainable systems perspective, right? So our challenge is when we have inevitable leaks from this, right? It's not a closed system. We'll have losses to the environment. And when we concentrate animals in places that can't deal with the amount of nutrients that are available, right? That's really our challenges in animal agriculture. Not that animals are good or bad, it's how we manage them from that standpoint that really matters from a health and a sustainability standpoint. So with that, I'll kind of leave you with some of these closing thoughts. And I think the key thing here is when we think about the health of a food system and where ruminants fit, it's getting back to the first principles of why did we domesticate these critters in the first place, right? I think this quote from 1950 is really key from Robert Hungate, kind of the father of ruminant microbiology, right? The ruminant animal, a small fermentation unit, it gathers raw materials, transfers it to its fermentation chamber, right? It regulates its passage, all these things, right? And it produces these incredible products, meat, milk, right? The fiber that comes from these ruminant animals. And I think this last sentence, right, is really key, right? To these advantages must be the crowning adaptation. The unit self-replicates, right? So when we think about all the technology talk out there today from a standpoint of our food system, it's really hard to beat the end product of 3.5 billion years of evolution, the ruminant animal, right? And its ability to take the solar energy that's not available to us and use it for this high-quality food production. So when we think about it from a standpoint of the bottom line, right, health of our food system, it's dependent upon all these interactions and these connections. I didn't really dig deep into this because, honestly, we could talk about this for a whole semester, right, from this standpoint, but it's really about those connections, plant, animal, human, and of course, soil. And as I put in parentheses, driving all the microbes, right? That's incredibly important. All these questions have converged, and when we think about sustainability or health, there are objective ways that we can talk about this and objective data to evaluate the system, but we also have to recognize it's also about judgments. Think about that example I gave you guys of the feed conversion. You can get a different answer depending on how you express things. Animal agriculture is about 11% of global emissions. It's not nothing. We should work to reduce it, but it's also, of course, not the single largest source in the world. And our real key here is when we think about animal agriculture, particularly ruminant agriculture, grassland systems, it's their ability to produce food, but also provide these other ecosystem services that are so critical for human health, for human flourishing. That's really key and important. So with that, thank you very much for your attention. Again, if you're interested in learning more, please check out AgNext at Colorado State. My contact information is there, and I think we have some time for questions. I'd be happy to answer any questions if you have them now, or briefly in the hall before I make my beeline to the airport. Thank you.
We'll take a couple of questions. Let me get the mic to you.
Thank you for your presentation. I'm interested in the methane gas generation. We've for years known how to minimize methane generation in grazing cattle. However, the economics have not been there. Simply, it costs a lot more to suppress it than you paid for. We're talking in the row crops about carbon credits. Is there any thought that we might get into methane credits that would then make some of these systems viable in agricultural production systems?
Yep, great question. So I didn't include any of that in this presentation, but I think that's an exciting opportunity for methane reduction. And one, I would say, just because it actually has some advantages over the soil carbon market in terms of it's a little bit easier to document, hopefully, and addresses two of those concerns that are always perennial issues in the soil carbon space, which is additionality, meaning you have to show additional carbon sequestration over your baseline management, and you have to demonstrate permanence from a soil carbon perspective. And those two are always a challenge from a standpoint of making a market work properly. For enteric methane emission reduction, if you do something today that's different than the past, you knock out that additionality challenge, and it's always permanent, right? If a cow today did not emit as much methane as she would have, there's never going to be a reversal on that, right? And so because of those two things, to your question, I think the opportunity in that marketplace will hopefully grow over the next several years as we have more solutions and we have more systems that help those kind of markets work. I think that's a big part of the challenge too, is the data and the cost in the system and making sure that producers actually get paid a fair value. That's always my concern in any of these markets.
I think with timing we're going to move on, but Sarah has her contact information here. She is going to have to fly out shortly, so feel free to be in contact with her, and let's give her a hand again for an excellent presentation.